Hey guys, so we are moving on to section 10.3, which is all about composite figures. So a figure that is made up of simple shapes, wow, I can talk. Simple shapes such as triangles, rectangles, trapezoids, and circles. So essentially we're taking a bunch of shapes that we've already found the area of and we're putting them together. That's what a composite figure is. And if you guys remember, when we did that vocabulary activity with the flashcards, composite was actually one of your words that was on there. So to find the area of a composite figure, find the areas of the simple shapes, and then we add or subtract them. Just depends on what the figure looks like. So sometimes we're going to be adding a bunch of shapes together, other times we're going to have a shape and then take another one away from it. So let's take a look at what this looks like. So notice that it does say if you are going to round, so I'm going to zoom in so we can focus on question 1. But if you read the directions, it does say to round to the nearest tenth if necessary, but do not round until the last step. That's important. We just talked about that today when you got your formatives back. Alright, so this figure does look a little weird, so let's take a second and talk about it. But what I do see is I see some parallel lines right here, 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 and here. Right, if we notice these have one arrow, which means those two lines are parallel. These have two arrows, so these two lines are parallel. That means that green figure there is a parallelogram. Okay, so I know for sure that we've got the area of a parallelogram. And then I also see in this figure, and hopefully you guys do too, that there is a triangle that's left over here. So the orange figure here is a triangle. And those two figures are just next to each other, they're connected, so we're actually just going to find the area of both of those and add them together. Alright, so let's start with the parallelogram. We know that the area of a parallelogram is equal to base times height. And remember that base and height have to be perpendicular to each other. So when we're looking at this figure here, it's actually pretty easy to see that this 5 right here is drawn perpendicular to the 8, which means that is what helps us get the area of the parallelogram. It's 5 times 8, which we know is 40 feet squared. So the area of that green figure is 40 feet. We've done that before, right? We can just cover up this triangle. You've done finding the area of that parallelogram before. So now we're going to do the same thing but with the triangle. Ignore the parallelogram that's there and focus just on the triangle. Area of a triangle is 1/2 base times height. And again, base and height have to be perpendicular to each other. So we luck out that we were given those right away also. We've got the height of 5, and it's perpendicular to that base of 10. So it's 1/2 the base, which is 10, times the height, which is 5. So that comes out to 25 feet squared. So all we're going to do is add those two together to get the total area. So I'm going to take the 40 feet squared and the 25 feet squared, and we get 65 feet squared as our total area. That's all it is. We identified two separate shapes that we saw, found their areas, added them together. Not that big of a deal. Okay. Number 2 is pretty similar. Hopefully you can see that there is a trapezoid right here. So that would be a trapezoid. And then sitting on top of that, there is a half circle, so a semicircle. So we would find those two areas and then add them together. So I am actually not going to do that one to save us some time because I don't want your video to be super long. But have at least that written down and we'll do that together first thing on Wednesday. Okay? Question 3 looks pretty similar actually to question 2, but it is actually much more difficult. So we have a couple of different things we're going to talk about in this one. Let's start with this trapezoid right here. Okay. So that's a trapezoid. So we want to find the area of that, and underneath it, that's pretty easy to see. That's a half circle. So we'll deal with that in a minute. I want to focus on this trapezoid. So I know that the area of a trapezoid is 1/2 the height times the sum of the bases. So base 1 plus base 2. And when I look at that, I can clearly see the bases, right? My bases are my ones that are parallel. So 3 and 7 are definitely my bases, but what I need is that height, right? And the height is this dotted line right here. So I'm going to actually redraw this picture so we can look at it a little bit closer. So this is our 10.2, this is 3, this whole thing is the 7.8. It's not drawn to scale, sorry, okay? Just deal. But we need to figure out that height right there. So what I'm going to do is put an H there, trying to find that. What I do know though is that this right here is a rectangle, which means this piece right here is 3, and this piece on the top is actually 4.8 because I can subtract. Again, I get it's not drawn to scale, get over it, okay? But what that means is I have a right triangle and I can find the height. So let me draw this triangle a little bit better for us, a little bit clearer. So this is the H we're looking for, this is the 10.2, and the 4.8. So if I have two sides of a right triangle, I can find the third using Pythagorean theorem. So I'm going to go ahead and do that. C squared equals A squared plus B squared. C has to be the longest side, so we know that's the 10.2. So 10.2 squared equals H squared plus 4.8 squared. And if you do the work behind it, grab your calculators out, we will get down to H equals 9. Okay, grab your calculators and double check. I'm going to grab mine too, just in case. 10.2 squared minus 4.8 squared, and that's 81, and I take the square root, I would get 9. Okay, cool. So I did have that right. We're good. That means then that I can plug that in for the height of my trapezoid. So, area of the trapezoid is equal to 1/2. I just found my height to be 9. And then base 1 plus base 2, so 3 plus 7.8. Alright, so if I figure that out, I get that the area of the trapezoid is 48.6 feet squared. So that's the green portion up here of my figure. Okay, then I also need that half circle that's at the bottom there. So let's go ahead and do that. So this orange here is a semicircle. So we know that the area of a circle is pi r squared. Since this is a semicircle, we're going to divide it by 2. So we really just need the radius of the circle. So let's take a look at that real quick. We found that the height of our trapezoid is 9. That means that this diameter here is also 9. So the height is 9 for our trapezoid, but the diameter of our circle is also 9. And to get the radius, we're going to have to cut that in half. So the radius is 4.5 feet. All right, hopefully you guys know that the radius is twice the diameter. Or the diameter is twice the radius, excuse me. Wow, I can't speak today. So let's do area of our semicircle. So pi times 4.5 squared over 2. I'm going to leave it in terms of pi. So plug in everything in your calculator except for pi. So 4.5 squared divided by 2, and we end up getting 10.125 pi feet squared. And then I know that my total area is the two of those together. So I'm going to add the area of my trapezoid, which was 48.6, to the area of my circle, which is 10.125 pi. And again, I don't want to round until the end. That's why I purposely didn't put pi in my calculator. Okay, and we end up getting 80.4 when we do put that in the calculator at the end then. So 80.4 feet squared. Plug that in the calculator and make sure I got that correct, because you guys know I do make mistakes. So make sure I plugged that in correctly, okay? Because these are things that I did a while ago. All right, so question 4 is pretty similar. We're taking some areas and adding them together. So we're going to skip that one. We're going to do that in class together on Wednesday. I want to move on to page 16 and look at question 5. So looking at question 5, we see this shape here, and it almost looks like a rectangle, right? And then these semicircles cut out. So it almost looks like it could be like a basketball court. But the area that we are looking for is this green area here. I'm going to shade that in a little bit. So it's here, here, and here. So it's almost like this hourglass shape. That's the area that we are looking for. So the easiest way to do this one, so the area of that green, I think the easiest way to do it is to actually look at that rectangle. So do that whole area, and then subtract off the parts that we don't want. So we've got a semicircle right here and a semicircle right here. So I would subtract area of the semicircle 1 and subtract off the area of the semicircle 2. And that will give me the total green area. All right, so this is the first example we're doing where we have to actually subtract. Okay, so rectangle's nice and easy, right? Area of a rectangle is equal to base times height. So if we take a look at our rectangle, we know that this base right here is 33. And if we look on the inside, it was drawn for us that it's 16 is the height. So 33 times 16, which gives us a total of 528. And then we want to look at those semicircles that are there. So area of a semicircle, we just did it in the last question. We know that it's pi r squared divided by 2. But we have to remember that we need the radius, right? So when we look at this area right here, this whole thing up and down is 16. That means that our radius is actually 8. So pi times 8 squared over 2, and we get 32 pi. And then actually we luck out because semicircles 1 and 2 are exactly the same, which means the area of semicircle 2 is also 32 pi. So this was for semicircle 1 over here. It had a radius of 8, and this one also has a radius of 8. Since we're cutting both of them in half, they end up being 32 pi each. So that means that the area of the green space is 528, and then we're going to subtract off 32 pi and another 32 pi. So the total area is 528 minus 64 pi. And then we can throw that in our calculator and get a decimal now. So that is going to come out to 326.9 feet squared. Okay. Number 6, we are going to set up together real quick, and then we're going to move on. So number 6 has a very similar idea. If you look, there is a big giant rectangle that's missing 2 pieces. So I'm going to draw in that rectangle first. It's this entire thing here, all the way to here and across and back up. So if you look, let that clear for a second, we can see this big giant rectangle and it's missing 2 pieces. So the area of the shaded region, if we can figure out the entire rectangle, so there's a big rectangle, that would be the red. And then if we look here, there's a little rectangle that I want to subtract off. And up at the top, there's actually this trapezoid that we're going to want to get rid of. So the area that is shaded that we're left with is what we're looking for. So area shaded is equal to the area of the big red rectangle minus the area of the small blue rectangle minus the area of the green trapezoid. So you guys are actually going to do that on your own. So take a second, give it a shot, and get the answer. And then we are going to move on to question 7. So these are regular figures. So find the area of the regular figures below, round to the nearest tenth, but do not round until the last step. So if we look here, we have a regular hexagon. Because it's got 6 sides, so hopefully you guys remember that. A regular hexagon has 6 sides. And the other thing that we know about regular polygons is that all of the sides and all of the angles are congruent. So I'm going to go ahead and put tick marks on all of these sides, and OG is also congruent to the others. So I'm thinking if we can find the area of one of those triangles, then we just have to multiply by 6 and we'd get our total area, right? So I'm going to take this triangle that's at the bottom here, which is HOG, and we've got this height drawn in. So it's M, the height is 10 rad 3. And I want to talk about that. So we know that the sum of the interior of the angles of a regular hexagon is 6 minus 2 times 180. Okay, so these formulas are coming back. We got to know them. Which means that the sum of the interior is 4 times 180, which we know is 720. All right, so the sum is 720, which means each angle, we can divide that by 6, and that's going to be 120 degrees. All right, so that means then that, for example, this angle right here would be 120 degrees. But because this is a regular hexagon, when we draw in all of those diagonals there, we cut that angle in half, which means each of these is 60 degrees. Okay, that means then that this angle right here is 60 degrees. Okay, and I want to figure out how long this segment is so that I can get the base. Okay, so we can use SOHCAHTOA, right? Opposite over adjacent would be tangent. So the tangent of 60 degrees is equal to 10 rad 3 over x, and we get x equals 10, which means mg is equal to 10, and the entire thing then is 20. Okay, so we're going to do area of one of the triangles equals 1/2 the base, which is 20, times the height, which is 10 rad 3. So we get an area of 100 rad 3. But that is for only one of the triangles, and there are 6 of them total. So we're going to multiply that by 6, and we get that the area is 600 rad 3 units squared. Okay, we will talk more about that in class on Wednesday. Okay, enjoy your day off tomorrow. Please make sure all of these notes are done, and I will see you guys on Wednesday. All right, bye.